Hello all, this is my first video on YouTube regarding DataDog. I have tried learning DataDog for last 3 days, and I will explain you what I learned in the website about DataDogs. So my objective is I want to send my metrics from my Java code to DataDog cloud. So I just tried out understanding what is DataDog and how we can do this. So what I will do is I will explain some basic concepts of DataDog, and then finally we will go how we can send metrics from Java. So regarding the DataDog, for example, these are all the sections I would like to cover it in this session. So regarding the objective is DataDog, is it really not like waking up and alerting us? It is more than that. It is something like we can see anomalies. We can create correlation alert, in the sense the root cause may be same, and multiple places the alert may come, but there may be only one alert we want to be alerted, actually, because it's all root cause is same. So that is, then we can collaborate with the team members within the DataDog about some graphical problems, not graph structure, along graph structure. Then it has alerting. It alert on Slack, alert on some more integration capability it has. So this is all. This is about DataDog, and actually from the goal it is more clear. Like see it one place we can see all your servers, clouds, metrics, apps, and you can work with all your team together. Okay, if I see this product features, it has many feature, like it has integration with all in the sense it can give metrics from each already existing technologies. It is already have a integration with existing technology. It's one click, like you can see that which technology you want to monitor, and it will automatically monitor that particular technology from the predefined metrics. Okay, so then build in real time. It's nice graph. Actually, human mind is very good at understanding graphs. So even though we have a good data, the DataDogs monitor has a very good rich in graphical tool, so it is easy to analyze it. And if for example, if I keep a cursor on one place, and it will show the same cursor on other places, something like that. So we can correlate at the same time what all happen in other places. So then this is how team can collaborate. Okay, so we can write our own custom collection, metric collections code within the DataDog agent, which we will see later. Okay, so this is all about DataDog introduction. Okay, so the problem with the DataDog understanding is need to understand the terminologies. To understand the terminologies, I will cover the basic terminologies, so that you can continue after this session. You can explore DataDog. Okay, so why do we need it? The problem with existing logs are very huge, and we need to parse many many logs we have to parse it, and even the parse pattern is not constant. We have to if we follow some pattern of in the logs, then only we can parse it like JSON. So and there are some problems which never identified from logs, like memory leak, the time taken by method. So no, there is no exception when the time taken by a method is having more than a usual time. So these are all can be alerted from kind of metric system, not from the logging. And we can predict that today we can compare that data with today and yesterday, this week, this Christmas or previous Christmas, how this data are utilized by how the systems are working like that. So do we need to implement analytics? Yes, we need analytics always. No, Datadog is not like not really like analytics, because it uses UDP protocol, and it does some aggregation on the data to make it lesser points in a graph. So it is better to have the much reliable analytics for your system instead of relying on Datadog. Okay. Okay, then let me explain about one how data talks when we need a Datadog. Okay. Assume that my system, my application has to send alerts to the system. My system has to collect the metrics on my application. Okay, so what I did is I can write my own code on atomic counter or atomic long, which that code can be packaged and it can be used within our code. What I can do is I can increment that code and store it in a file. Okay, so I can view the file. I can see that which metric is utilized by which time. The thing is that the increment and operation and all, it will be in the application, but there will be separate thread which will go through all the metrics and keep the entry in the file every periodic time and reinitialize that variable. That is a legacy way of introducing metrics in our application. Okay, but the problem is this is good until there is only one machine you are maintaining and to viewing the metrics. But if it is multiple machine, the problem, there are three problems. One is that the file got created, the metric file has to be cumulative. It has to be passed across all the machines to see some unique, like for example, this, if I have multiple machine, so each machine may be logged in by some user, so so all the files I have to take and correlate to find out how many users are at the real time and during this time. So that is tough in this legacy behavior. So what we need is the central agent where it will collect all the metrics from multiple machines, which can send that information to the graphical tool. Because the second problem is, even if you got CSV file or whatever file you are writing, it is hard to predict and see the values. Okay, so there comes that Datadog kind of a graphical system which will take our inputs and we can draw nicely graphs with tags, slice and star schema, like fact and dimension, where tags will be a dimension and fact will be the metric value. Okay, so that is the second problem. We need a graphical user interface, we need a centralized agent. The third thing is that centralized, when you think about centralized, that data has to come from your code to there. So if it is TCP, then the real actual code will get affected, or real system may get affected. So what we have to follow is we have to follow some UDP kind of protocol over there. So that is the three problems that solved by company called HC. They have created some DD agent. Okay, I'll show you that. So the HC company have they came up with a new agent called StatsD, which is Node.js. They have implemented, and it is UDP, which will measure. So this agent will be running in some common place, which will give you APIs. If you call this API, it will send the data to the centralized way. It will be like something like that. Okay, so this is the basic concept, and what DataDog is implemented is extended this stats concept, and they came up with the dog stats. Okay, this is their dog stats agent, where this is their dog stats agent. Actually, collector, there are dog stats agent or DataDog agent will have dog stats. I think you now you understand that the difference between stats and dog stats. Dog stats is DataDog custom stats implementation. Okay, so our application has to send events to stats via UDP. So once the agent is collected the information, it will do aggregation, something like aggregation. The stats support backend server. It is responsible for aggregating local metrics sent from your code, and it is forwarding to forwarder. Forwarder will call DataDog cloud with the HTTPS. The collector is something different, which will this is something like push methodology of pushing the data to dogstats agent, but this is pull method, something like collector, where some piece of code will run and collect the information from your machine and send it to forwarder. Okay, this is a different way. Okay, so this is the architecture of DataDog agent. Think so you can this all links I will add to that video. You can look into it, okay, for more details. So this is about all infrastructure architecture. So how I can push the data to how I can push the data to DataDog cloud, right? That is the second question. So that we will see. There are three ways I can send the data to DataDog agent. One is agent check submission, dogstats submission, HTTP API submission. Okay, agent. So first API is down. Okay, where API is something here. API submission is something like we can send the data directly to dogstats cloud via HTTP RESTful service, where they have implemented their payload and all. Looks like we can send data from here to dogstats, but they have added some rate limiter. So if you keep sending very frequently, if you are sending, you will get rate limit and denial of service. Okay, so you have to, it will be that rate limiter will be in the header, so we have to respect when we are sending directly events to dogstats client. Okay, then the API, and then this is the agent check. Agent check is something like a Python script which will be run in a frequent interval. Okay, which will be running in the frequent interval, which will so what you have to do is you have to there is an interface called agent check, which you have to implement it and write your own code over there. Like for example, if you want to measure the system CPU, this agent check interface you can add, and you can call system CPU and all, and you can say self.cause, and it will send the data. Agent will collect the data, something like we can. This is something like where we can write our own code within the agent, so that agent with frequent interval our code will be called, and it will collect the information and it will send it to DataDog cloud. Okay, but each interval, if the piece of code is very huge or something, execution time is more, then the next execution will be delayed. Okay, so and this is the agent check. Okay, this is agent check. There is one more thing called integration, where integration is something like if it is, this is all related to our own custom metrics we want to collect from the system. But if you want to collect information metrics from the existing technology like Redis or MongoDB, then there is we can use integration concept. Integration is something they have given protocol how to implement integration for any common tool that we want to monitor. Then once you implement that, you can post it post your submission, that integration submission to DataDog team, and the DataDog team will verify, and if it is good, they will add it into their library. Okay, this is how we can create an integration. But DataDog already has so many integration, like for example, already it has this all integration. So you can just click on it, and the integration will be ready for your own database something. Just added only JMX, so my Java JVM is able to be watched now. My it is agent. I just opened a JMX port, so DataDog able to catch all my Java related stats, and it is pushing to DataDog cloud. Okay, this is called integration. There is one more thing that is called DocStats client, where it will that I told, no? This side we have to insert. This is pull. Agent check is interface is pull methodology, but there is other one is DocStats client, which will where we will push the metrics from our application code to DataDog agent. Okay, that is called DataDog D client. Okay, DataDog D server it is, but the code which is running on our application in Java code, it will be DataDog D client. It is called DataDog D client. Okay, so I will show you that. Okay, this is a JIT library. You can see JIT library. This is a DataDog agent JIT library, all implemented in Python. You can review this data, because here is the one. Here only you have to write agent check interfaces within the DataDog agent. Okay, this is the DataDog agent GitHub, and this is the library which can send data to DataDog statistic server. This is for Java, and you might have for your own technology, you might find your own clients, so that you can use that client and you can send the data from your application to cloud. Okay, no, first it will send it to your agent will send it to your cloud. Okay. So for Java side, it's very simple. You have to add one dependency, then you can start within your code. You can start calling increment, record, cause, everything. Then it will automatically send the data to DataDog agent and agent to cloud. Okay. So library season installation is very simple. Just log into DataDog. Okay, once you can use 14 days free trial. I have only 1 day left, that's why I'm making this video. You can log into this, create an account on DataDog, and it will ask you to install agent on your system. Installing agent is very simple. Just copy this call command into your terminal, and just enter. It will install the agent on your machine, because it has API key and all. It will got installed in your agent. Once agent is installed, it will automatically send Mac OS related stats to DataDog cloud. Okay. Once it is installed, you can see here also it is already running your DataDog stats D. Okay, this integration is within the integration, you can, if you want to integrate any other third-party service, you can integrate. Okay. Then so installation, I did it. It installed like this. Okay. Now I should know how to view the installation details, right? So this, you can see this is this code where you can how to start your DataDog agent, start, stop, restart on Mac OS, and configuration file will be here in the DataDog agent, because some metrics, some of the metric name will be start from the agent, then your own metric name append. It will be appended from the agent, like agent purpose is the root of the agent name. Then if you metric name you have, both will be appended with a dot. so it will frame one single metric. Okay, so then you can see this once you have configured, you can see the DataDog commands which you can run it. Okay, for example, I can run like info. Okay, if I run info, then it will tell you what it is doing, what version it is, where and what all integration I did. I did a JMX integration. Okay, okay, I didn't told about this emitter. I think I told. Okay, there is a collector forwarder and emitter. Docstat is server. Collector is agent check interface. Dagstat tree is something API is calling in Dagstat tree and to send the metrics, and both will collector and Dagstat tree will send to forwarder will send to DataDog cloud. So all these things, all this information about your service can be seen here. Can here if it is because I stopped my JVM, that's why it's saying there is no metrics collected. Okay. So to start Java JMX monitor, we can do this enable with this one. Now let's go to metrics, related to metrics. Okay, so metrics, when you think about metric, right? Oh, this I covered already. Yeah, metric, when we think about metric, it's the one unique metric is actually metric name plus tags. Okay, how you can visualize it as like a variable name equal to some value. Okay, if variable name is metric, okay, variable name is metric and value is metric value, variable value is metric value, and there are types related to the variable, that is metric type. Metric type is something like a counter, gauge, histogram, set. These are all types. Okay, where that tag comes is, tags is something like a fact dimension table where you can see that each fact will be associated with multiple dimension, so that we can group based on some tags. Okay, for example, if I have user is visited from US, user is visited from India, then you can aggregate that the number of users visited only in America, or one number of users only visited in London, something like you can aggregate with a different dimension that data. Okay, so that is tags. Okay, one metric is something like a metric name plus tags. Okay, this each unique path is one metric. Each unique path is one metric. Okay, the important thing is we have only 100 custom metrics per host is allowed. Okay, so we should effectively use that metric with the tags. Tags should not be ever growing. It should be something very specific, like enum, like America, US, or role, something like admin, supervisor, something like a list of enums. It should not grow. It should be fixed, something like fixed, so that your tags won't exceed the limit. Okay, so it's 100 tags per host. So if you have 3 hosts, you might have 300 metrics is possible, but the thing is you can spread that 300 out of each one by something like every host you can segregate. But the point is every tag, every metric is associated with the host name also. So for example, you have a declared user visits. Okay, user visits, then user visit also have a tag from host 1. It will be attached with the user visit host 2. So if you have 10 tags declared, then for host 1 it will be 10, host 2 it will be 10, host 3. So total 30 we consumed already. It's the same tag, though it is the same tag, but because of host name is appended to the tag, we will see that 30 tags, 30 metrics we have created. So that is one drawback, that I cannot use 280 tags, something like because host name also added here. to the tag, even though the metric is same, but host name makes it a unique path and creates a new metric. Okay, so hope you got it. Then so metric types I will tell you later. Metric type. Okay, let me complete tags, then we'll go with the metric type. Okay. Oh no, we'll cover this metrics also, then we will go. Okay, so for example, there are types is nothing but a variable type. Okay, like counter is a long integer, you can assume in counter as that way. So counter is something, they give the example is the page views. Okay, how many people can visit. So what you can do, you can increment, and it will send a value to doc.static agent, and it will forward to cloud. Okay, so there are multiple level of aggregation is maintained. Okay, one is that aggregation at your agent. Okay, that doc.static server itself will aggregate the data, because cloud will accept only per 1 second data. 1 second, what is the value? 1 second, it cannot go further granular. Okay, so maximum is something like 1 second granularity. So, and one more thing is, this cloud will not accept very frequent request from the agent. So what it will do, agent will send only 10 seconds configurable time. In 10 seconds, every 10 seconds it will send the data to cloud. Okay, so 10 second, each second it will aggregate. Okay, each second. So if you have two requests within milliseconds, and it will sum it up, aggregate it per second, and it will for that second it will store, and the second it will store till 10 seconds. It will store the whole 10 second data. It will send in one shot to cloud. Okay, so then, so this is the first level of aggregation. Okay, second, if you see DataDog monitor graph will be fitted with only maximum of 300 points. Okay, 300 points. So if you want to see per day graph, then each point will be 5 minutes, 5 minutes, so that it will 280, only 280. If you zoom it, then it will, the 300 points will be among that period of interval. It will be that period of interval, it will sum it up, so that your graph so there is one more aggregation happen on the fly, I think. Okay, in the DataDog monitor. Okay, so this is one more thing. Okay, so we've seen the counter. Then Coj, the thing is, Coj will, within that 1 second, what counter will do, it will do sum it up and aggregate it. It's aggregation. But Coj is something like when the 1 second is over, what is the latest value it will take. Okay, it won't do sum and all. It's Gauge is very specific for kind of deviation happening, like memory utilization, CPU utilization. So it frequently, it is something like just to monitor that a particular time, that point of time, what is the value is enough. 1 second, what is the value of the, so is enough. So that is called a Coj. Okay, histogram, when you create a new variable with a histogram, right, it will internally create a multiple metrics for that histogram. So your metric name will be only this much query time, but it will create count, average, median, max, 95%, all these metrics it will create. The purpose is mainly it is for query time. Okay, this is for query time in the sense how much time it took to execute a particular task. Okay, so that time, it will, if you pass that time, how much time it got executed, it will make one metric with count, average, medium, max. Purpose is you need to plot the graph different ways. Okay, one is you want to plot the graph by max value. Max value is something like, if any sudden burst happen, then max value will clearly tell that okay, this second this much is the sudden burst, it will tell you exactly. Okay, but you don't care about if you don't want to care about sudden burst, you always want to the median value. Median is something, I will tell you, median and 95 percentile. Median is whatever sampled, whatever value we got. Okay, it will sort it out and it will give the intermediate number. Intermediate number is the middle number. Middle number is the median. So plot the graph according to this one. Sort it out and send it. 95 percentile is something like this is 100%, right? 100%. This much is a peak, sudden burst. So you want to ignore some 5% of that kind of sudden burst. You want it from count something like 95 percentile values on the 95 percentile values. So the 5% will be ignored. Only that 95th percentile value will be counted for a graph. Okay, so that you can have some way to ignore sudden burst. Okay, that is why that is called a 95 percentile. Okay, so then what else is there? Histogram. Okay, then service check will say whether the service is up or not. That's a simple counter, some simple metric to say whether service is up or not and what is the reason. Based on that we can alert the system. And set is something like to identify the unique people, unique users visited, something like that. Okay, so these are all the data types on the metrics. And I think I didn't told you about tags. Just to remember that tags is giving a dimension, right? So tags can be first tag, second tag, third tag, like that. But it is better to create a tags with tags as a key value pair, so that you can do something filter on the key with multiple values like east, west, and you want to see east and west, or you want to see region something XYZ. So that is possible if you declare a tag as a key value pair. So always declare with the key value pair, it's better. I will show you the example. For example, here you can say here you have, see, this is always like from is something like a where condition, where you can say equal to this. Okay, here it is something like SQL group by, some group by functions, and this is something like where class. Okay, so where class you added role Cassandra, this is a one tag you have added it. Also you will get a only Cassandra related CPU user. But if you want to see all database, all different roles, then just give role. So it will give you multiple lines for each role, multiple graph. It will give you multiple graphs. Okay, then that's why that is our advantage of key value pair. You can use it. Okay, but ensure that tags are limited, so that metrics will not grow bigger. Okay, and there is something called roll-up function. I will show you in my let me show then. No, only so there is no data. I will go to last one day results. This median numeric. Okay, let me see. Something like roll up is something like we can add a roll up function. Okay, roll up function, the benefit of roll up function is it will by default, if you see this by default it is 20 minutes, right? 20 minutes. What we can do is here we can edit and say roll up sum of period. Actually you have to use the same sum here also. Okay, sum by 30 seconds, right? So save it. brand Coke. Or say brand Scout. Here if you use some, here also use some. So you say 60 seconds and save it. Actually what it will happen is it will show you in everything in 60 seconds interval. I don't know, now it is not showing. Okay, minimum is 1 minute, 60 seconds. I think we cannot further divide here. Okay, so regarding this, what is time board, what is screen board and all, you watch that YouTube video on a series, DataDog series, you will come to know how to create this dashboard and all. Okay, then what else is there? Metrics we seen, types also seen. We have seen metric types. Then now what we'll do, we'll read about how to integrate our Java with statistic client. Okay, let me, I think I can close something so that it will have a, so as I told earlier, we have to add only one dependency and we will be adding this code. Okay, if you see this code, this is the statistic client. This is a non-blocking client. Non-blocking in the sense it will use UDP protocol and it will send the data using UDP. So here I added my metric name, common metric name. Okay, common metric name. Here you use a local host because your agent is running on your local host and it is listening on this port. And this is a tag for the whole client, this client. Okay, so now if you declare foo, it will be my.prefix.foo. It's a metric. Okay, you can also add a tag also. There is like here, this is a, so there is one tag that's attached, and this tag will be attached to all this thing, and this tag is additional tag, one more tag with the metric called my.prefix.back, my.prefix.back, and one more tag is this one. This is additional tag. This is array where args. It will accept multiple tags actually. So metric name, value, where args. This is the standard way we can add a metric with the values. Okay, I think that's it for this session. Thank you for watching.